At first glance, this looks like a standard domain question, a logarithm, an inverse sign, nothing unusual. But look carefully. This function is secretly asking you to satisfy multiple restrictions at the same time. Miss even one of them and the entire answer collapses. Can you spot all the traps before JEE does? Let's think sharp.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
Here we have been given the function fx is equal to this, whose domain we need to find out and then compare with this given format. So the function is this and we need to solve for three distinct conditions and find their intersection. First part is to solve the inverse sign condition. The argument inside sign inverse must sit between -1 and 1. To solve this safely without cross-multiplying variables, we split it into two inequalities, left side and then later we will solve the right hand side. So here we take -1 to the other side, it becomes +1, then taking LCM and solving the numerator a bit, we get this. Now we don't know about the sign of 2x plus 3, but we know 2x plus 3 whole square is positive. So multiplying both sides by 2x plus 3 whole square, we get x plus 8 into 2x plus 3 greater than equal to 0. Taking 2 common, we have this. Next, using wavy curve method, we can find out the critical points, which is -8 and -3 by 2. And since x is greater than 0, which means x will lie only in the positive regions, where -8 is included but -3 by 2 is not included, because if x is equal to 3 by 2, then the denominator of this argument becomes equal to 0 and the function becomes undefined. So let us keep this inequality and solve the right hand side first in exactly the same way we have solved left hand side. Please note over here, I have to take -3 common, and when I have divided both sides by -3, the inequality sign changes. Here clearly the critical points are 2 by 3 and -3 by 2. So using the same wavy curve method, we'll consider the regions where x is positive, which means -infinity to -3 by 2, where -3 by 2 is not included, and 2 by 3 to infinity, where 2 by 3 is included. Now let's intersect these two domains. The first domain is this and the second domain is this. Now on the number line, we have -infinity to -8, which means everything up to -8, and then we have -3 by 2 to infinity. So then everything greater than -3 by 2 is included in the first domain. And the second domain, -infinity to -3 by 2, which means everything less than -3 by 2, together with everything from 2 by 3 onwards. Now for the intersection, we keep only the portion which is common to both. So if we look at the left side, -infinity to -8 lies completely inside -infinity to -3 by 2. So it survives. And on the right hand side, we see the common portion is 2 by 3 to infinity. So the final intersection is, on the number line, the common shaded portions are everything up to -8 and everything from 2 by 3 onwards. And let us consider this as condition 1. Next, part 2, we will see the logarithmic conditions. For the rational log term, 1 by log base e 10 minus x, we have two separate rules. First, the log argument rule, which says the inside of a log must be strictly positive, which means 10 minus x greater than 0, and that implies x must be less than 10. And let's call it condition 2. Second is the denominator 0 rule. The main denominator cannot be 0, meaning the log itself cannot be equal to 0. So, which says log base e 10 minus x is not equal to 0, which means 10 minus x is not equal to e to the power 0. And that gives me 10 minus x is not equal to 1, which gives me x is not equal to 9. Let's consider this condition 3. And now comes the easiest part. We don't solve anything new. We simply intersect all three conditions. From the inverse sign condition, we have these two allowed regions. From the logarithmic condition, we must stay to the left of 10. And from the denominator condition, we must remove x equal to 9. So we simply combine all the restrictions. So combining the first and second conditions, we have x must belong to minus infinity to minus 8 where minus 8 is included, 2 by 3 to 10 where 10 is not included. So the second interval gets cut off at 10. But we are not done yet. Since the logarithm is in the denominator cannot be 0. So we got x is not equal to 9. So we simply remove 9 from the domain. Therefore, this. Now it's just a matter of comparing this with the form which is given in the question. And we get alpha is equal to minus 8, beta is equal to 2 by 3, gamma equal to 10 and delta equals to 9. But the problem asks for the value of this. So finding out the sum first, we get 35 by 3 and 6 times 35 by 3 gives us 70. So the correct choice for this question is option C, 70. Always isolate your denominator restrictions before diving into long algebraic intervals. If you successfully caught the x not equal to 9 trap during our opening check, drop a thunder in the comments. Subscribe to Think Sharp Ally and let's move on to question 20.